Alright, so last time we managed to implement the text extraction part for a PDF file. So let's try to remember how we did that. Basically, it was just running main, and yeah, we extract the text. We also get some errors for some like the rest of the data, but we can ignore them. Because we'll do something like, okay, we pass through all the streams and try to extract text, and today we'll try to extract images from the PDF file. And honestly, I was surprised by how easy it was, but maybe it was, I don't know, just for this case. So let's see first of all how let's recall how we did for the text. So in PDF files, we have these objects, right? So you can see objects all over the place. And sometimes inside of these objects, we have like something like a dictionary. I think this is how it's called when you have two less than symbols and greater than symbols. And then after the dictionary, you have a stream. So in that case, you have to look at what kind of decoding you have to do, and for this one you have to do a flate decode. So I guess it comes from inflate or whatever. And yeah, this part right here is some binary data, and after you deflate it using zlib, because that's what PDF files use for text, or I guess for flate decode, you get back what you just saw earlier. So this kind of text, I guess it's not really this exact text. It also contains like information about where on the page it's placed, I guess font size, all of that crap, and then text is inside parentheses. So if you do something like search for what's inside parentheses, you get back the text only, right? And what I found interesting, I guess, about images, or at least for the PDF file that I created with an image, is that it uses this DCT decode. And DCT decode is, I guess, a different type of decoding that you have to do. And it's actually no decoding at all. It's in case you have an image, this thing right here is just the binary of the image. So if we copy paste this entire thing into a separate file, we actually just get the image JPEG. So let's search for oh, let's search for end stream, right? So if we copy this entire thing, I mean it will work just like this, and we do image.png, and then we paste. Honestly, yeah, doesn't look right. I guess using a script for that should do it, but yeah, I mean let's try to do a script, I guess. But yeah, the idea would be, well, we could do something like, let's try to copy image PDF into image JPEG, right? And now, yeah, it's scuffed, but I guess this now should work, image.jpg, right? So if we open up image.jpg, we get, so I guess since that's pretty easy, why not just try to create like a data structure? Also probably a good idea to have this thing as an argument, and yeah, like have a data structure for these objects so we can parse the PDF file properly. Like we have an object, like a list of objects, right? And each object inside of it will have some stuff. In this case, it can be a dictionary and a stream. So I guess another list of objects, basically, like nested objects. So here you have another object with a number. Then it's another object, right? And so on and so forth. Here it's an object with a stream. So if we go back to PDF, we have something like you have booleans, real number, integer, strings, array, dictionaries, which is, I mean, I'm not sure like what this dictionary is. Maybe it's like length is this and filter is flat decode. Type page, parent, this thing, resource that, contents, media box. Like it's a bit weird. And then what's this number for? Like this one is really funny. So yeah, maybe yeah, I don't know how. Like it's such a weird kind of dictionary. But maybe slash is like string, right? And this thing is like the key and the value or some shit like that. Yeah. Anyway, we have dictionaries, streams, and null object. And I guess objects start with two numbers. Right, like I think I saw, yeah. Objects can either be direct or an indirect. Yeah, like whatever. Because I can see like 40 object 5 6. Oh, then it's 11. I mean 12 7. Maybe they are not in order, so yeah. And then you have this xref at the end, which I guess how this PDF thingy works is that you define some objects like this with data inside of them and whatnot, and then you have this xref thing here, which is like the template. So it's like, okay, you use the first object on the first page and so on and so forth, but yeah, maybe something like that. But yeah, anyway, let's just try to extract information out of a PDF file. We don't care about the like parsing it and displaying it because we have like enough PDF readers. We just want a PDF data miner or something like that. All right, so let's just go ahead and have an enum for all of these kinds. So let's do type def enum, and let's say it's so it's gonna be like object kind, and yeah, we have I guess object boolean, object real number, object integer, object string, and I guess string is enclosed with parentheses, or hexadecimal within a single angle bracket. Okay, nice. Object name. Okay, so names start with slash. It's funny. I mean, I didn't notice name because it's not with an a tag. Okay, so those things that start with slash are names. Interesting. Array is, so object array has these kind of things. Object dictionary and double angle brackets, object stream, and I guess object null, which is null. Okay, comments start with percentage sign, so that's not that interesting. Let's do object kind. Okay. Right. I guess I'd also need to do like a data structure for the object, so probably it's gonna be something like struct object, but let's type defit, and then we have like object d or something. So with the object kind, we have the kind of the object, and then I'd say we could use a union, right? And then inside of the union, we can use like the structure stuff. So can we have like float value? Let's do for boolean, let's use int boolean, right? Boolean value, right? We can have that. Float value, but we need to use different names for these things. If I remember correctly, I have to use different names. First string makes sense, then the name, which is also just a string. Okay, so collections indexed by names. I mean, it's still weird because yeah, like I don't know how dictionaries work. It's pretty strange, but anyway. Yeah. I mean, I guess I'll call this one bool, this one real, integer, char pointer, string. Right, then have char pointer for names, name. Then it's gonna be interesting. We have array, which I guess we could use DS, you know, dynamic array and then call it array, and this thing is gonna hold objects. Then we have dictionary, which I'm still gonna use array for it, dictionary, but I guess in here we need a tuple. So how I can do that is have a structure let's call it object kv or whatever, object kv, and it's gonna be, it has to be like a name, so probably char pointer name, and object t, let's say object, right? Because here it says that dictionaries are indexed by names and are collections of objects, so I would assume that, yeah, it's like object kv. Okay, and after dictionaries we have streams, which is gonna be still char pointer. It's but yeah, should it be unsigned char pointer or char pointer? Like, doesn't really matter that much. Could be unsigned, just to better indicate that it's bytes. You can see it easier. If it's unsigned char, it's like a byte. Or I guess char is a byte, but to me, when I look at code and I see unsigned char, I think of it as, oh, he meant using like a binary format or whatever, right? And then it's the null object, which I guess if it's null, we might not want to use any of these, or I don't know. I guess that's fair. So that's how I would create a data structure for these things. And yeah. Now I guess if we take a look again at our sample PDF, we can see that here starts an object, then we have a dictionary and a stream inside of it. So each object can apparently have more than one thing. But this is like one object, this is another object. Oh, so that's the object number and generation number, and defined between obj and end obj. Okay, so I guess we have like indirect objects, which are gonna have this object number and generation number, and then inside of them is gonna be a list of objects. Now let's try to also have that. So we might want something like type def structure indirect, or yeah, I don't know how to call it. Maybe it's like cos object, but carousel object structure. Yeah, I mean, like these, yeah, I guess these are like cos objects, and then these are used inside of like I don't know. I'm just trying to think because I really don't like the naming. It's like so weird. You call this thing objects, but then you have another object. So I was just thinking what name would be good for these outer objects. Because yeah, let's call these thing objects because it makes sense, right? And then let's say I don't know, we call these things like obj or something. Well, I guess the indirect object is somehow part of this tree then, or at least that's how I would see it, because if objects can either be direct, it might mean that embedded in another, well, it's like embedded in another object, right? So if it's a direct object, it means that it's something like, let's check this for our reference. It's like directly embedded, right? Like this dictionary or like this stream. And then you have the indirect object, which is numbered with this number, and then obj. So these are the direct objects, and obj is the indirect object. So I'd say that the indirect should be part of these types and be part of the object data structure. So that's how I would see it then. So let's say that we add here object indirect. So all of these are direct objects, right? That's how it makes sense. And indirect object is a different type. So null doesn't really have a value, so I won't do that. And then we have the array, which could we reuse array, or we could say objects or something. Objects. I mean, we could just reuse this thing. Here it's a dictionary. Yeah, like why not just reuse, but I'd say the same thing for string and name. So let's just keep this one as array and this one as objects. Right, like the indirect objects. Oh, actually, yeah, because what's gonna happen is that type def struct indirect object is actually gonna have the objects array, but it also has this object number and generation number. So int object number generation. I mean, obviously they are useless for our purposes, but use object. Oh yeah. So that's how I would say, okay, this is object T. At least this is how I would see this thing be done. Okay. So without that. Okay, so yeah, how would we parse this thing now? I don't really want to build a lexer and parser and whatnot, so it's probably gonna be something like we split the string by spaces and whatever, and we try to find the next word, sort of like in a regex style. So that's that. Okay, at least we can skip, you know, comments and stuff, and then okay, we find a number, another number, and then obj. So yeah, it's like we expect to find this kind of structure. It's going to be interesting at this point, but again, I don't think I care about this xref. I only care about objects because they contain information, and you know, most specifically about plate decode stuff. So okay, anyway, let's see. So how can we create a parser? So the parser is probably gonna return an integer, obviously. You like failed or success. Then parse PDF, decent name. Then we have probably the bytes of this thing. And as return, we should have a list of objects. So if I create a type def struct PDF, let's just call it PDF, PDFT, it's going to have a dynamic array of objects, and probably also gonna have other stuff in the future if we expand this thing. So it's gonna return a PDF, and then we have the int result, and probably we'll use defer for this stuff. Okay. So yeah, I mean, the thing is that string slice doesn't have that many useful functions, I'd say. Maybe we need stuff like starts with and all of that. Yeah, I mean, maybe we can add them as we go along, because surely we'll need to check, like, using a string slice might be the easiest way to work with this thing. So yeah, obviously here we are gonna need buffer length for that. So I think string slice let's call it slice whatever, and then this string slice init slice buffer length, because yeah, we are gonna need to check if it starts with percentage and we just go until a new line or something like that. That kind of makes sense. Okay, it's gonna be like skip the what, the maybe let's also define token, because we might want to split by new lines, right? So we'll see how we do that. So let's just imagine we try to do it. So slice tokenize. Here we pass our slice, what we want to split by, and where we want to write. Okay, and this thing should return 0 if a token was found, and 1 if the slice was empty. Oh, interesting. And yeah, as I said, something else that I want to add is probably, because we have trim left, trim right, which just remove this character, but I'd like something like this string slice starts with, and then here you pass in a string. Right, that'd be interesting. So starts with. guess. Probably, yeah, the easiest way to do it is with mem compare or something. Or, string compare. So can we just strcmp wait, this thing exists? Okay, I mean, if we have mem compare, then that's fine. But if we have mem compare, we should also have str compare. And this should actually be the starts with. String and compare, maybe it's better because it also has the string length of str. We could check if the thing works. So then we'll do string slice starts with, we pass in token and percentage sign. Let's do printf percentage d. No, the best way of coding the printf debugging. Okay, so then yeah, we could just remove all of this stuff because we won't need it for now. Damn, it's a lot. But yeah, as I said, we don't really need it because we are basically rewriting this thing to work with a data structure instead of just searching for the text. So how can we use parse PDF here? We define the PDF, which I just say equal to 0. Okay. And then we have result is equal to parse PDF. Pass in the buffer length, and the address. Oh, so here it was just that. Okay. If result is less than 0, failed to parse the buffer or whatever, and then we can just return defer and so on. And I guess we could just do that. But at least that would give us the cause of the error or something. So yeah, something like this. Okay, let's see what happens if we gcc and run main. We get a 0, so it means that it starts with that, right? It makes sense. So it's like, okay, we can ignore the token and go to the next line. So we might want to have this as an iterator. So wait, something happened. So you might want to have this thing as an iterator, the split by new line. Right. And if we find starts with percentage, then we ignore that line and we got the next one. So how can we do that? Well, while this thing is not equal to 0, because as I said, this thing returns one if the string slice is empty. So while this thing is equal to 0, then we find a token, otherwise we don't find one. Okay, then if we find that this thing starts with the percentage, we continue. Makes sense. It's like skipping the comment. And now let's just break. Let's do something like char pointer line. It's gonna be just for visualizing it. Owned token line. And let's print f the line. So it should be the object one. Pretty cool. Okay, I guess this line should be split by spaces. I will comment here, we should have an obj now, like maybe x, y, obj. Right, because we have the number thing obj, and then we are gonna parse this entire thing, then again, and so on, but here it's different, xref. But yeah, we are gonna ignore xref. So if we have anything else than this, we might just want to report that happened and skip it. So we have the token, which maybe a better name for it is gonna be line. Okay. And we could say, okay, and the token. So now we can split the line by spaces. So what would happen if we string slice tokenize the line with a space into token, and let's call this one word or something. In this case, we should get 4. That's correct. What if we do it again? We should get 0. And if we do it again, are we gonna get the object or how? Yeah, okay, nice. So this is how we get each thingy. Okay, I mean, it sucks, but let's put the word there. So here we get the word, and we can have the indirect object here. So indirect object, I mean the, okay, let's put everything that's related to this thing here. So like token, word, and all of that. So here is gonna be object. Let's make it equal to 0. We should initialize the object. So dynamic array init objects, probably reference, and here we need to do size of object t. But yeah, we are gonna need the implementation for dynamic arrays. So initialize the list of objects inside of our indirect object. And yeah, first we tokenize by space, so we get the first number, whatever that is, and then we have to say something like object dot object number is equal to a toy word. Simple. Then we do the same thing here. Generation number. Okay. Obviously we should free word afterwards. And here for the PDF file, I would say something like ds dynamic init pdf objects, yeah, reference, and this should be still object t. Interesting. Size of object t. That's nice. Okay, so we initialize our PDF file. All right. We initialize that, then we have this while loop over our slice. We skip the lines with comments. Then we should have this xy object. We take the x, the y, although we don't care about them, but I thought, well, it's interesting to have it. Why not? Let's printf that information. Let's see if we parse it correctly. Object number and object dot generation number. Let's see. Yeah, we parse it correctly. So after we read all of that, it's gonna be something like we should have a direct object now, right? Or more. One or more direct objects. That's what I would say. So yeah, it's gonna be interesting how we read all of that. and at the end we should have end obj. Right, so it's something like we have a direct object, we have another one, and then we have end obj. I mean, even here, I guess it makes sense to do some error checking, but for now, let's just ignore it. But yeah, would clearly make sense to have here something like, okay, let's check if it's a number, let's check if it's actually three words like this, but you know, since we are not building Lexer, yeah. Okay, so the next thing is to check for direct objects. That's gonna be a pain. I mean, this one starts with two smaller than symbols, so this is one of the checks. Then we have stream. We also have numbers and other stuff like that. Okay, but at this point, we need to redo our string slice. Like everywhere where we have the tokenize, we probably should check for error code, but yeah. So we tokenize by new line. So now we should be on a direct object. For example, we have to check if it starts with this or if it starts with stream. So let's see. Yes, string slice starts with. So if it starts with this thing, then we have dict. What the fuck? I thought I put a 0. Anyway. Else if it starts with the word stream, we have a stream. And I guess we can have a square bracket. It starts with a square bracket. The other option is if it starts with a single thingy magingy. Right, that makes sense. It's a string then. Okay, it can also just start with a slash, but that's weird. So, you know, let's take it into account. So if it starts, maybe let's check the order, right? So we looked if it starts with double less than, that's a dictionary. We looked at this case, it's an array. We looked at stream. We also looked at the single less than, we looked at slash and we have numbers left, so integer, real, and boolean. So on the else case, it's just the numbers, booleans, whatever. Okay, so here it's string, here it's string, array, name. And here we should have end object, so I'd say, okay, we check that, and we just skip it. We don't really care, right? And then we have another read. Well, yeah, you can have comments inside of that, yikes. I mean, maybe writing a parser for this thing would make sense, but I feel like, you know, I want it to be as simple as possible, because it's not really about like writing a parser. But yeah, you can have like weird stuff, so like every line you have to make sure that you don't. So I guess here we do a new line, right? If it's a comment, we skip it. If it's well, maybe it's a easier way to just I mean, yeah, makes sense, but we should have obj, then, you know, we split whatever. Basically we parse an obj here. So yeah, like maybe the next step would be to have a function called parse object, and it does this thing and then also this stuff. And then we have a function for parse dictionary, function for parse stream. That sounds like a decent idea, I'd say. So let's do something like parse object. But see, I would maybe pass in the slice itself. So how would this one work? Because I'd like to pass in the slice, right? So let's do a ds string slice pointer slice, and it should return out objective pointer object, right? So then the first step would be to split by new line the slice, obviously, like this. We split it by new line, and now I can say we should have this part. And after we split by new line, we have to skip all the comments. So skip comments is going to be something like while the line starts with this stuff, we string tokenize it. I guess it makes sense. So it's something like we tokenize the line, we get the next line. If the line starts with the percentage sign, we get the next line. And then we should have this stuff. So we copy all of that. We don't need object anymore because we have it. We initialize. Oh, it's not an object, it's an indirect object. Yeah, here I need to use others. Okay, and these things work like that. Yeah, let's just imagine that, we don't need error checking for now. And then we are inside of the object. So we need to parse the inner part somehow, parse a list of things, and then we should have end object. Oh. Okay, so we skip the last line. And as usual, every time we skip, not really, we do that just here and probably somewhere here. But yeah, after we read the end object word, well, I have to figure out how I want to do this one. But yeah, so result is equal to 0. Let's do here a defer. So after we read this thing, how do we know that it's done, right? Let's have something like parse object here. Parse object, and it gets in the slice and the object itself. Right. So we don't really need all of this. And this should be indirect object meaning. So we have to do this one multiple times somehow. Maybe until it returns error. So something like while this thing is 0, so it parsed successfully. We do something like dynamic array append into PDF objects, and we do object. So we append it. And let's print f it for now. Something like object dot object number. Well, let's just print object number. And then maybe we can break it. So just to see some result for now. So it's gonna be something like Okay, and now maybe error checking makes sense, right? So if this thing, wait, I said that 0 is good, right? Yeah, 0 is token found. So if it's not 0, here it means that we expected, let's do 1. We expected like the end of string. No, we found end of string, but we didn't expect end of string, pretty much. If this thing is not 0, again we return defer 1 because we expected end of string. Or I guess we got end of string, but we didn't expect end of string. It was like comments at the end, basically. But I wouldn't display an error because why exactly I wouldn't display an error? Because I guess it's fine if you don't, if you're not able to start parsing it. But if you start parsing it and you fail, then it's the bad part, no? So here, yeah, like we have to return 1. At least in some place. Like you couldn't parse another indirect object because there was no indirect object. That's the point, or something like that. Here we say we should have xy object. So if we don't have that, it means that we don't have an indirect object, so we can also skip it. I mean, I guess the right way of doing it is to skip the comments outside, check if it's possible to have an indirect object. So if we have this line, and then call to parse indirect object once we are sure that we have this thing. I guess that's how I would do it if I had a lexer and a parser. Right, like this thing should skip all the comments, then check if then, like with the look ahead token, basically we check if we have an object structure, and only then we start parsing it. But I mean, it's fine, it's whatever. My guess is that if we run it now, yeah, we should see the object number. Yeah, I really think we should do that, like have a function int skip comments string slice. Like it's gonna make our life much easier, my opinion. So should do something like if ds string slice starts with, if the string slice itself starts with percentage, no, if it doesn't start with percentage, we just turn, let's make it a void because it cannot really fail. So if the string slice doesn't start with the percentage, we don't have any comments, so we don't have anything to skip. But if it starts with percentage, we have to tokenize. So wait 1 second. So we have to tokenize the slice. Well, that's decent. That's a decent approach. So while string slice tokenize that, if this doesn't start with a 0, we can just like break. Right, so skip comments is gonna be something like, well, if our slice starts with a percentage, then we have to do something about it, and that's just splitting by lines and stopping once. Actually, yeah, this sucks. This freaking sucks. So maybe it's a better idea to do it like this. While our slice starts with percentage, we have to split tokenize. So I guess that's the way to do it. While the slice starts with percentage, we tokenize by new line. We don't really use line for anything, but that makes sense for me at least. So then how are we gonna do this one? Indirect object can be there. We are probably gonna do something like skip comments for slice. Then we need a line. So we skip the comments, right? We take a line. If we couldn't find any line, I wouldn't really say it's an error. Maybe it's the end of file. Right, it could be that. Because it's in the beginning, and if it's in the beginning, then we are good. So I would just probably just return, or like it's gonna be a while loop. So let's do while 1 or something. We skip comments. We split the slice, like we take the next line, obviously. If there is no next line, then we can just break. Right. And then we need some kind of if statement. If x, y, obj, we have to But see, here comes the issue with splitting by line. If we split by line, we remove all of this information from slice. So how can we do this without splitting by line? Do we have something like ds string slice? We don't really have an empty function, do we? Empty. We don't really have an empty function, so return. We could do something like is equal to 0. Alright, so if the string slice is 0, so this one returns 1 if it's empty. So if it's empty, we break. This can also make sense. Okay. But yeah, now here's the interesting part. What if we straight up assume that we ignore? I mean, it's still a bit annoying. Like the only thing that we can see now it's objects, but there's also this xref. So if the string slice starts with xref, we have xref thing, but otherwise we have indirect objects. So that's my logic. Right, so let's do if we parse an indirect object successfully, because we assume the only thing is going to be an indirect object. And that's my idea. So if we successfully parse it, we show it, we whatever, and then we break no matter what, just for the purposes of this example. It's yeah, so it parses it. All right, but we don't need to do skipping this thing, so we read a line. If we cannot read a line, it's kind of impossible, so yeah, like it is what it is, but we still have to error check it. So at this point I'd say we can log errors, because if it fails, like here we must have an indirect object, because the string slice is not empty, we have some text, it's not a comment, so it has to be an indirect object, or I mean the xref, but we are not there yet. Expected a line but found end of file or something, I guess. At this point we must have xy object, so yeah, it is what it is. Not sure how we can check if this thing fails or not. I might have to look into that myself, but yeah, we parse all of that and then we expect an end object. Yeah, I mean, I deleted the helpful thingy, but like at this point here at the dot dot dot, we expect to have multiple small objects, I'd say multiple direct objects, and then we expect the end obj. I mean, I guess it's fine. Probably the next thing would be to have a small parse function for each thing like this, and we check it in order. So first we check for dictionaries because it's the most explicit. I mean, I guess arrays are also explicit, names, strings can be either of these, and then all of this, and also stream is pretty obvious. So yeah, I'd say that's the next step, right? I mean, I know I removed some stuff which was useful at some point, like that big if statement. Oh, this one. Let's take it, because why not? And let's go back to this thing. So here, it's like we should have one or more direct objects. So we split the slice by new line. And let's do something more cool. Oh, I guess more cool would be to just copy this. Wait, what? So if this thing starts with end obj, it means that it's I guess break. Oh, wait, what? Because yeah, here it's gonna be another while loop, so it's gonna be a while one. I guess so. A while one, and here it's gonna be similar. So if this thing is not 0, then it failed. So yes, log error expected a direct object or end obj keyword but found end of file. Let's return the for one. That's how I would do it. So it's like, okay, we found XY object, then it's a list. If we don't find anything, then it sucks. It is what it is. Maybe here we need to check if we found at least one thing, but I guess it's a null object, so that also works. Okay, so if we find end object, then we are good. It means that we completed this direct object or more. Yeah, and then we check for dictionary, for string, for stream, for array. But even better, the same way we did it here would be to check the slice, not the line. So if the line is empty, sucks to suck, it's an error. right? And here we use slice. So if the slice starts with any of these, then we have to split by line, or whatever, how this thing is implemented. For example, if the slice starts with end object, yeah, it makes sense to do a tokenize by line, because we want to skip it. But I wouldn't say we need to check anything. So we just remove a line. I'd say that's good. Okay. So if the slice starts with end object, we skip a line and we break. It means that we completed everything. So we go back and we start skipping again. But if we find like smaller, or this or anything else, we need to do something different for each one. So yeah, I'd say let's try to do these things next time. I mean, I guess it's a decent progress. Let's check what happens if we, whoops. I mean, let's try to make it work by putting skips. So let's do something like this. Let's comment this thing out and let's do skipping. Okay, so now it actually skips all the line until it finds end object. So if we remove this break, we should actually find multiple objects, right? We find all the objects and then, you know, expected direct object or end object, but found EOF. And that's because if we check sample PDF, we have this xref, which sure we can handle it now. So let's do if this string slice starts with slice xref and this is going to be the else, we just break. So we don't care about, wait, I guess else happens every time, and then we have an if statement for the success status. So now we get all the objects, but we need to parse the contents of it. So that's next time. And yeah, as I said, I don't think we care about xref. So let's just remove that. I mean, you know, makes sense. So we want to do this part next time. So yeah, I guess we'll see each other in the next one.